Right, introductions there. Okay, so I'm the last one who's speaking. The rest is video, so hopefully still a bit of energy left in you and in me. The titles are appearing in the black background there. It's all right. Unconventional computing. I was trying to, let's say, match a bit of what I was doing with the misbehaving machine. And actually, like, if there's behaving, there's misbehaving. And as I explained, like this morning by Stella, for instance, like, there's a judgment value, of course, to say, like, okay, this is behaving, this is misbehaving. So it means that there's an outside observer that is looking at this behavior, or there's some kind of moral conduct and so forth. So I'm interested in, let's say, unconventional computing. After Guy, it's a perfect example of unconventional computing. You have neural network, not made on one of those, but in our biology. So I just want to go through a bunch of stuff I've been incorporating into my process and showing examples of other people, not necessarily robotics, about how we can break away from, let's say, a cybernetic model into something which is another kind of model that will eventually help us to make the machine at the same time behave and misbehave. So basically, after like probably too many years of programming computer, I just want to be lazy and basically not program computer and have the machine do the stuff just by itself. And one of my arguments that I say in most of the work that we do with robotics, there is huge misalignment between the body itself and its behavior. Because the body is assembled, so basically you're going to shop for all the little parts, and you hope that the body will behave because you're just programming and so forth. So there's a huge disconnect because basically this body and the control mechanism and everything has been on for like, I don't know, quite a few decades. So this is not something that you can just have a model and say, okay, it's going to work. I'm going to blink a LED from a value of 0 to 127, and that's going to show the emotion of what I'm stating at. So this is a piece, because we just reconstructed it this year. It's about robot misery. So it's based on by Victor Hugo. So there's many elements in that unconventional computing. So this one is more about what they call from AI morphological computing. So basically, you build the thing, you don't have to program any behavior. The structure will do it because of its interaction with physical world and the tension and so forth. So this machine is having like spasms and convulsion and so forth. So basically, as a programmer, I just randomly trigger little pulse in there. Because the whole structure is so much in tension, it will vibrate on its own. I have no way to tell where it's going to go, but I can probably make it more or less have spasm. But if you try it without doing by a model, you end up usually with beautiful synchronized swimming as a sequence of action. And this is something I want to get away from it. Another part of this, similar to the next work as well, there's another part of computing that happens in the eye of the beholder, which I would say like more like it's almost like cultural computing and so forth. Because these are small robots, and I say these are dancers. People look at these machines and they give the gift, or they give the competence of the object that these things will actually be dancing, regardless of not doing it. For the robot perspective, maybe it's a series of movements, series of trigger, a series of way to not knock the other dancer out and so forth. But from the beholder, if I establish a code, automatically what I put in my situated context is automatically augmented, and I haven't put one more line of code in my program or my model. That's what I like about it. Same thing with a robot that touches people. It's called the blind robot. And I did play with the fact that it's blind, so I created an empathic situation where you would let yourself be touched by the robot, because the robot has a positive intention. He's blind, he's to touch you. So if you tell the people that this is a machine and is want to poke at you, people will be like, not quite. So I made actually measurement with this. I'm going to go back with this. And finally, recent work, try to make audience misbehave. This is the work we're going to complete at the end of the year. That's me and Bill Vaughan. We're building exoskeleton that audience is going to wear. So 25 selected lucky people going to be part of an hour performance where we're going to make them misbehave or behave according to whatever random sequence that we have. We don't know yet. We're making it. And this is another example that I'm working on. It's actually you cannot read. It's like because it's so close to, because I'm from Canada, from Montreal. So it's called a jumping Frenchman of Maine. So it's very close to Montreal. It's actually like the cases of people who had like Tourette syndrome, similar thing. So it's totally like erratic behavior, and they can push each other to do something. So it's basically misbehaving situation. So this is something I want to work on as my next installation. So just because of the title, and a lot of time I just like conceptual art. You know, basically it's all based on the title and the little right up there. Then after the beholder puts things together, then suddenly it's working. You know. All right, so a sub-branch, because unconventional computing, you know, it's like conventional, let's say it's a computer, so if you say then the rest is unconventional, pretty much include a lot of things. But if you think about like looking at nature or robots or something, so you can make it based on nature, you can make a model and try to simulate it or emulate it, or you can basically just build it. The problem when you build something, it's to master it, it's very difficult. I mean, we've been doing this for a long, long period, and now we're just so happy to jump into digital world where everything is sanitized and just push the button and you can replicate it and so forth. You know, bioart, for example, like, you know, things die. So like, all these things are hard to master, but at the same time, there's no model. So local stuff, chunky moves from Melbourne with Gideon. So let's say on this side, you have like particle flowing. It's an amazing piece, by the way. So of course, simulating gravity and so forth, and things like this. This is typical particle systems. And on the other side, you have, let's say, the analog version by Lawrence Mal stuff. It's basically little pellets of styrofoam floating around, propelled by ventilators. You have to master them so they spin and they don't get dispersed and so forth. But basically, you both have particle system. One is done on a computer, virtual, and this is totally physical. Not a single cent of computation went in there for some similar visual output. This is a winner of let's say artificial life. So he makes amazing installation. Just try to find some moments. So basically, he makes fluids. So imagine you have your screensaver, try to emulate this. So basically, he mixes oils and all kinds of particle, you know, a lot of physical elements in there. It's more like an alchemy process than actually try to do this with a model. So at the end of the title, the name of the artist is up there, from Korea, Kim's. If you look at try to model this on a computer, it's highly complex and almost impossible. So this is how he makes it, but time flies. Olafur Eliasson, this is actually an exercise I give to my robotics students, try to make a garden hose behave. You know, it's random machine on its own, but if you start playing with the flow of water, interruption with the lighting and so forth, you would have different quality of excitation. Old machines were programmed with water, like in Arabic times, like 1,000 years ago and so forth. So doesn't necessarily need like a computation, either a max MSP maybe to trigger the water. This is actually a very beautiful system. What you see here is like little elements that heats up, and there's a laser plane here, and all these things is basically looking at clouds somehow. It's like different temperature that will create these barriers. And then you see it in the front of you. So instead of actually making this as a model with particles and so forth, you just do it. You just have to control the temperature and so forth. Even in visual arts and Hamilton, for instance, sound installation. So instead of making noise on your computer and so forth, you just put thousands of sheets of paper in a room, you put microphones in the right place, then people will generate the noise for you. So you don't have to program anything, just have to wire a few speakers and so forth. Same thing with moving that piece of fabric here is all done by people swinging in the front, and it's all connected mechanically together. So you basically, you harvest the chaotic motion of all your people, you put it inside. Of course, you could have made this with motors and all that stuff, but the whole context, the system you create as that kind of strange computing and you put it back in the context, kind of reformulate everything around. NetCam, these are basically something where you can see the wind on the surface of a building. Basically, there are little aluminum plates just floating. Chris Burden is having a lot of fun in making these sculptures. They basically just drop them, happens randomly. Frédéric de Wilde, recent piece, all these things are spinning. He's got a Geiger counter with radioactive material there. So basically it's a random process, but you manipulate it as well. So people, they all think they're mad scientists and looking at this thing, try to influence the whole system. So there's a lot of example, and David Bowen, for instance, where he takes telemetry information and replicates those somewhere else. So there's tons of example where, just the way this whole thing moves is not something which is planned in an engineering perspective, nor with a model and so forth. This just happened now at this very moment. Just maybe old stuff from Simon and Bosch, full installation of chaotic systems. The brothers, I forgot their name, I'm sorry. So it generates basically sound from a chaotic movement that is triggered by a central motor. These work, and so forth. So basically, just to sum it up, this is a good example, like to have I'm sitting in a room by Alvin Lucier. So basically, he's playing with the harmonics of a room and the echo. So instead of making this as a model on a computer, you basically do it in a room, you record it and re-record it and so forth. But at the same time, there's a quality in this recording that probably no digital process would recreate because it has something intrinsic about it. All right, so how do I put this in action? So that's the spasm machine. I'm mostly speaking over it. So these are like the machines that are, I'll cut the sound because I'm hearing myself too much. This is a heretic machine that shakes a cage when you pass by. This is begging. Harassing machine is aiming for your balls when you pass by for the man. And this one has convulsion. So all these machines were programmed using a mixture of morphological computing, like I mentioned, and a mixture of some sumption level. So there's actually, again, no way to know what's the output of the thing. Because usually when it's behaving, I can only know the level of excitation it has, depending on the number of visitors. But the actual output, I didn't care so much about it. At that time, a lot of things were triggered randomly, because I don't really believe fully in interaction at that level of wiggling your hands in the front of the sensor, of what we've seen before, to the action-reaction is not necessarily happening, so we just get rid of it. So these are shots from done this summer in Pittsburgh, people playing with the robots. This is a piece I've done here in Adelaide with the Australian Dance Theatre. The main point I want to show is that people had actually some kind of exoskeleton or some prosthesis put on them, but the whole, let's say, way it was being manipulated was not because of the machine, the way it behaves, it's because how the dancer behave with the machine that makes the total behavior. So the robot on itself was not really interesting as a movement, but the combination of both created something. And the only way you can get this going is by rehearsal. They have to train with the object and so forth. And I'm just going to show, because these things, people never see those. This is us rehearsing with these objects before, trying to figure out if it can. So you see, you get an idea about the strength of these elements and so forth. So in this case, it's really these things, when they get back on the back of the dancer, the machine is not just the machine on top, it's the combination of both. And morphological computing, if you look at these little funny robot jumping around, I would really challenge you to try to model this with a computer or physics. So basically they have a behavior, they start advancing in the front because they all start vibrating in a certain way. So there's a robot we call Stumpy at the AI lab in Zurich that I found little cute. Then I said, okay, I'm gonna make a dance piece with this. So I'm just gonna show you a little bit of this, because I have 5 minutes left, I guess. So just lower the sound. What is important with this is, like, when people describe this machine scientifically, they talk about gates, and of course they talk about functioning machine. And in this case, I'm only interested in malfunction or misbehavior, depends. So I was way more interested to look at when they're crawling and do all kinds of things that were not planned for. But what happened is, of course, if you want to look at this from a real theater perspective, by the way, I'm trained in theater and I did a lot of performances. So when I do this, it's like I just want to get away from any kind of modern dance and mostly have a pastiche of it. So basically this is fully, we push it in direction another in terms of energy, but the rest of it, the position of the robot, it's basically quite random every night. So if you have a good night, it will be good. Otherwise, sometimes the show is bad, but it's not, I mean, honestly, it's not my fault, but if the robot wants to go there, I can stop it and try to make it go back, but sometimes I can't, and so forth. So it was really, like, in terms of the dance, kind of a real deconstruction of it. So that was quite enjoyable for me. And let's say more remarkably for these robots, especially if we go back to this morning with Tidal and Simmer in animation, I did a lot of little psychological tests with people. I showed them usually one robot and I asked them, how do you feel about the behavior and so forth. And they would say, well, this is walking and blah, blah, blah. They were all really function-based. But systematically in all the tests that I've been running so far, as soon as you put two robots, this is where they start labeling the robots as dancing, which was quite an interesting result I find at this stage. It appeared only once, somebody said, oh, this looks like it's dancing. But systematically, this changed totally for the same movement. I take same movement to robot, put it together, try different configuration. Okay, another kind of unconventional computing. I was interested, of course, in doppelgangers. Then it's a work I've done with Brandon Ballinger. It was interesting in generating odd shapes. So what we do here, to generate the shape, it's nature. That's a specimen found in nature. So basically you take biological malformation and we just do a big process of rapid prototyping and 3D input into the copy as a robot. So we spend a lot of time in the process. So basically, instead of putting this inside a computer, we just use nature. So with the blind robot, so I'm just gonna play this one. So it's a very simple mode of interaction. You sit down, the robot touches you. But what I did in terms of finding out what kind of competencies the robot was given, I did a lot of psychological testing. And of course, the robot understands the movement of the robot if you say that's a blind robot. If I say my control variable in this case, I say, well, this is an instrument that wants to measure your heartbeat or your body temperature and so forth. And the other one I say it's a blind robot. So I wanted to go from, let's say, a personal touch to an impersonal touch, from an instrument to more behavior, not a function. So, because touching and measuring is more a function as a behavior. So, and what I did, of course, in terms of narcissist, I did mirrors in the front so people can watch themselves. And the first thing they do when they see themselves is taking a selfie of myself being touched by a robot. Okay, so I can just put Bill and me being played upon, and so it's going to run a little bit. You have to imagine like there'll be 25 of those. You need at least 1.50 meters of safe zone, because when the strobe lights are fully on and you're waving your arm like this out of exoskeleton, you could injure the other. This is not so strong, and of course. The piece is about Inferno, it's about punishment and reinforcement and so forth. The idea about being stuck in exoskeleton is the infinite loop of being in the boredom of being a machine. Because that's the thing, if there's a hell, for sure there would be something similar like this. But I don't think so. It's not there to torture the people, it's really to play with all kinds of expectation. Same thing as the blind robot. The moment is when the arms are lifting up and approaching the person. That's the moment. This moment is like your first kiss. It cannot be recreated afterwards. Because this is the moment. Same thing with the suits. When they have it on, it's been half an hour. People go like, what the hell is going to happen? And then the first motion is totally unexpected. And what they do for the first... we had people with us like for hours, for instance. But the only thing they do, guess what? If you have this on you, they watch themselves moving because they try to integrate this force motion, which is not coming, let's say, like when Stellark was doing a simulation, this is force from the outside, it's way softer, but still there's something about watching yourself, and all the time you say, well, careful, watch over there, what, and they try to, it's a very, very funny reaction that eventually they lose through time, but we have to play with this. I mean, of course, it's much more interesting to make people afraid of a movement that will never happen than to put them fully on, like in a crazy movement, of course. It's all part of the strategy. Thank you.